Let's look at multiplying binomials. Here I have a very simple binomial, and suppose that we have a number outside. We want to maybe double this binomial. So we want to multiply it by 2. Now, if I just put a 2 there like so, that would indicate I'm just multiplying it with the first term. But I want to multiply it with the entire binomial. So you will see parentheses around binomials. That means they are grouped together. So we're asked to double the whole binomial. In other words, multiply everything by 2. So 2 times x is 2x, and 2 times 1 is 2. Now, when I go to write that answer, I need a symbol here. You always need a symbol because that's, you have to indicate that it's addition in this case. If I don't put something there, it kind of looks like maybe you're supposed to multiply again. So that's not quite right. So I recommend using maybe arrows to help you keep track of what you're doing, especially as they get more complex. So again, to review this, 2 times x, I wrote the answer, and then 2 times 1 is a positive 2, so I need to write that. This is the correct answer. And that was a monomial being, multiplying it with a binomial. So it's like you're distributing the 2, and we call it the distributive property. You're taking that 2 and placing it with all of the terms in the binomial. Imagine something a little more complex. Maybe there's another variable here. Let's try it. 2x times x, well, that's 2x squared, and that's because x times x is x squared. And then 2x times 1 is a positive 2x. Whenever you multiply something by 1, it doesn't change it. There's our answer to this problem. Again, you're taking the monomial on the outside and distributing it. Well, imagine there's another term out front. What you're going to do at that point is very similar, and it's very logical, I think. You're going to sort of repeat the process with that first term. In fact, I like to start there. So here's what I mean. Suppose this binomial, in other words, these are together for some reason, this binomial is supposed to multiply with this binomial. How are you going to do that? Well, in some textbooks and teachers, you will hear the term FOIL, the FOIL method. But it's just very logical. It's the distributive property. It's what we just did, only you're going to repeat the process. So here is what it looks like. You start with the first term, that 3, and you're going to distribute that to this binomial over here. So 3 times x, you write the answer, and then draw that arrow, and that's just a trick to help you stay organized. 3 times 1 is a positive 3, so you're going to write that. That 3 has been distributed, so it's finished. You're not going to revisit that. Go to the next term and repeat that process one at a time. So 2x times x is 2x squared, and you're just going to put that again. So this is like you're saying, this is my third answer. 2x times x is 2x squared, and one more time, 2x times 1 is a positive 2x. So you'll notice you distributed 4 times. You now have 4 answers, 4 terms. Well, this is mathematically correct, but we do simplify it, meaning we tidy it up until it's as far as it can go for simplification, and then that's our final answer. So let's look at what that would be. And for standard form, we always start with the highest power monomial. This is a 1, this is a 0. Oh, here it is. This is the highest power we're working with. So this term is going to come out front. Notice you don't need the plus sign in front. Okay, so that's written. And what's the next highest power? The unwritten 1. There's 3 of them here and 2 more of them here. Combine those and you get 5. 5 of them. You don't change what you're counting up. You have 3 apples and 2 apples. You have 5 apples. It doesn't change. Those are dealt with. And that just leaves this constant that goes last. So this is our same answer, but it's now in standard form from highest power to lowest power.